All right, so in your calculator, of course, what we are focusing on right now is creating the tables. This part of the calculator cheat sheet is what we are doing, okay? So the problem we were working on when we left class on Friday was this one that dealt with deer population. So if you have messed with your calculator, and I know I have since then, that equation, this equation is not what is in my y equals. So I want everybody to go into their calculator in the y equals, and I want you to be sure that this is the equation that is in there. And if you are uncertain, then no, bless you, and I will help you. All right, and then in the second part, we did table set where we started at 0 and then we did our change in table to 4s. So as a reminder, that is second table set. And so you would put in, what did I say, 0 is what we started at? And then the change in table was 4s. And then second table. And this was the table that we had created last week. Okay. All right. So we have done the work on this page. We had looked at what the carrying capacity, which we said, hey, this is our limiting value, and we had established that at 177 deer. Okay, so just to kind of bring it back up to date where we're at. All right. Part E says, when is 95% of carrying capacity reached? Okay, y'all, this is our limiting value. This is our carrying capacity. So this is 100% of capacity here. So now in part E, it's asking for 95% of carrying capacity. So it's asking us to find 95% of, and our carrying capacity we found to be 177. 95% is also the number 0.95. The word of means to multiply. And we're going to multiply that times 177. Okay, now, right now, this is where my calculator is at. Here's what's nice. I need to do this multiplication. I can do second quit, and all of that stuff, the table is still memorized in my calculator. Second quit is how you get back to a clear screen. So now I'm going to do 0.95 times 177. And so 168.15. Now we've been dealing with all the math. What's this number? 168.15 what? Here. Now, did it ask me to find just the 95% deer capacity? No. It asked me for when this occurred. Okay, it didn't ask for the population. It asked me when this occurred. So if you go back to what we defined as our function is n, which is number of deer. So this is a function value. When would be years. Okay, so here's what we've got. If you were to look at this in a table, What always goes first, function or variable?
Variable.
Variable, and in our case, it was T years, but in our calculator, that's the X. And then we have N, which is your deer population. And in our calculator, that is Y. And if we go back to our table, so I didn't get rid of anything here, so I can do second table and I can get back to that table. Okay, so when I'm over here, this means 0 years, 4 years, 8 years, 12 years. I'm looking for 168.15 deer. Well, here's 6 deer, 82 deer, 169 deer. So would you agree with me that it's somewhere between 4 and 8 years? Okay, so we've established by looking at the table that it's between 4 and 8 years. But I need a closer answer. Okay, so right now my table is set to start at 0, and the change in the table is every 4 years. But I want to hone that in. So I'm going to go back to table set, which is second table set. And I know that it's between 4 and 8. So I'm going to start at 4 and I'm going to let it go by ones. So I'd have year 4, 5, 6, 7, and 8. And now I can go back to my table. And here's year 4, 5, 6, 7, and 8, and I'm looking for 168.15. Okay, so now would you agree with me it's between year 7 and 8? Okay, so now I've honed it down and I know it's somewhere in here between year 7 and 8, so I don't have to worry about this part. So I'm going to go back to table set. And now I'm going to start at 7. And I'm going to go even smaller. So I'm going to go every 0.1. So that would be like 7.1, 7.2, 7.3. And now I'm going to go to the table. And again, I'm looking for 168.15. All right, I see one, it would be between 7.8 and 7.9. Would you agree with me on that? All right, so now we know it's between 7.8 and 7.9. Let's go just a little bit smaller. So I'm going to go second table set. Now I'm going to start at 7.8 and I'm going to go every 0.01. So that would be like 7.0 or 7.81, 7.82, and so forth. And it's not exact, but that's pretty close. You could even go smaller. You could do it between these two and go 0.001, but this will be sufficient. So I found 168.17. So we found 168.17, and that was what, a 7.83? Yes. So it says, when does this occur? I would say approximately, since we didn't get the exact number, 7.83 what? Years, because we're on the variable. So the purpose on this one is I wanted to show you how you can go back into that table set and get it, your answer closer and closer and closer to what you need. So you can keep the same equation in, and then you can go 0.1, 0.01, and so forth. Okay. All right. So now we're gonna do a new equation. So go into your calculator, y equal, and I want you to enter this equation. And then we'll read to see what our table set needs to be. Out 6x. Now, one thing I want to show you again with whatever makes the easiest or most sense to you on your calculator, there's two ways you can put in a squared. You can do the up arrow and then the 2, or x squared is used enough that there's actually an x squared button on your calculator. When it's squared, you can just use that and then the cursor will already be down there. You don't have to bring the cursor out of the exponent. But whatever makes the most sense to you. Minus 2 raised to the x. Now that cursor is in the exponent, and so I need to right arrow over and do +3. So that +3 is not in the exponent. Okay. All right. So we've got our equation in, so let's read and see what our situation is. Suppose the function f of x equals, describe a physical situation that makes sense only for whole numbers between 0 and 10. All right, so when they tell me that, they're giving me a hint to start where on my table? 0. Now, this is where you need to be careful. What's my change in table going to be? 1. Because I'll have a few times some people or students will think it's 10. Well, that would give me 0, 10, 20, 30, 40, 50. And this is just saying between 0 and 10. So we wanted to go by net ones. So second table set, 0, 1, second table, and we now have our table. Okay, so I have my table. Now I need to see what it asks for. All right, before I finish reading, I just want to remind you that in a table, now this, we don't know if we're talking about hours, minutes, ounces. I mean, it doesn't tell us. So this is just the variable x. But here is my question. Variable goes first, so we know that to be x, right? And that's what x is in my calculator, so we're okay there. Per the notation that is here, what is my function called? F or f at x, either one. But we know in our calculator that's y. So it's f because of that letter right there, okay? So this says for what value of x, so is it asking me to find variable or function? Because it says for what value of x, x is my variable. Does f reach a maximum? So that means we want the f value, which is your output. Your x value is your input, your y value is your output. And it's saying just between the numbers 0 and 10, we want to look for the biggest number over here. Okay, so I'm going to just, right now it's looking like 155. Oh, there's 169. And then it starts decreasing. So that tells me that my largest function value was 169. And the question is asking, when does that occur? So I come up to 169. When did that occur? When x was what? 7. So this first question, for what x does f reach a maximum? The first question, it reaches its maximum when x equals 7. That's the first question. Now, if I knew what we were talking, 7 deer, 7 hours, but we don't know, so I don't have to put anything on it. And then it says, and what is that maximum value? We're at 7, what's that maximum value? 169. So this would be F at 7 equals 169, and it's asking for that maximum value.
You're gonna keep off if it doesn't look like that, or if you say. This is not, does it have to be written?
Not unless it specifies. I would like it to at least say F equals 169 because that's specifying that it's the function. Okay, all right. Example 3, we've got another equation. So my first thought is to clear out my equation and enter this. But let's take a look at this equation. What's going on with this equation that has not occurred on any of the other equations that we have entered in our calculator?
Not X, just 3.
Okay, what is this called? That's your function. There's 2 variables. And if I put an X here and an X here, then I'm saying W and N are the same value, and that may not necessarily be true. So right now I'm like, uh-oh. Well, let's read and see if it fixes the uh-oh. All right, somebody. How do you pronounce it? What is it? Oh, no, I'm saying, how do you say this name?
Oh, I don't know.
You may want to guess? Sure, okay. So that formula is used by weightlifters to determine the weight M, and M is my function. So let's go ahead and do that. I'm going to say function M, and what does M represent? Weight. Is equivalent in a single repetition to N repetitions of a weight W. So I don't know yet what I'm going to call my variable, because right now we have 2, which sometimes we have 2 variables, but when we're dealing with the table, we don't. All right, so they give me this equation, and then it says it applies for up to N equals 10 repetitions. In this exercise, we consider a weightlifter who bench presses several repetitions of, and what does it do? It gives me the value of W, doesn't it? So since it gives me the value of W, I'm going to come up here, and in my equation, I'm going to replace that W with 260. So if you're bench pressing 100, then you would change it with 100. All right, so what does that then leave my variable to be? N 10 what? So that tells me how to set up my table. It says up to 10. So if I wanted to know exactly at 10, but I want to know how much the weight is at 0 repetitions, 1, 2, all the way up to 10. So this is number of repetitions. So we're just going up to 10. Okay, so now we can put in our equation. So in the calculator, it will be Y equals 260 over 1.0278 minus 0.0278, and in place of N, we'll put X. So the reason, and I get your question, Savannah, because it's like I see W equals this, N equals this, but because it says up to, it's talking about anywhere from 0 to 10. So they're not giving me a specific number of repetitions. Yeah. And then on part A, where it says make a table, now they're telling us where to start and our change in table. So your first step in your calculator is to enter the equation, which is up here. The second is your table set. And what are you going to start at? 1. And the change in your table would be 2. 13579, it goes by twos. All right. So I have gotten this one in. That's what mine looks like. All right, so it wanted me to make a table, so I'm gonna do that. And we did it here. What goes on top? Variable in number of reps. In my calculator, that's your X. And then we have M, which is weight in what? Is it pounds? Well, since 260 is, yeah. That's what I thought too, but I taught this at 9:30, so I have a heads up on you. All right, so then we're doing our answers for 1, 3, 5, 7, 9. All right, do I have anybody that lifts weights in here? Yep. So I don't do heavy weightlifting like 260, but I do functional strength training, so I have hand weights. And I just increased some of my exercises up to 15-pound dumbbells. I can tell you the first lift of them, it feels like 15 pounds, but the more you do, it starts feeling heavier. That's what this problem is doing. It's saying 1 repetition, if you look at your calculator, is 260 pounds. When you hit 3 repetitions, it now feels like 275.31 pounds and so forth. So 5, I got 292.53. 7, 312.05. 9, 334.36. And that's what this particular problem asked for, was to make a table. So this is, if it was a test question. Now on it, if this were on a test, I not only want to see the numbers, but you need to still do this part here as well. Okay, so don't neglect that part. Okay, says what single bench press weight M corresponds to 7 repetitions of this weight. All right, this is what is given. Will 7 be N equals 7 or M equals 7? Look, it says 7 repetitions. Oh, this is my number of reps, that's N. So N equals 7, so they gave us function or variable? Variable. How would I write that in functional notation? M at 7. Now it's asking us to go ahead and find that weight. So I'm going to come up to my table, find 7 repetitions, and it's 312.05 what? Pounds. Now, I was looking at WebAssign this morning. Just pay attention to how many places it asks you to round. It might say to the nearest whole number, to the nearest 1 decimal, to the nearest 2 decimals, so just pay attention, okay? All right, part C. What number of repetitions in of this weight corresponds to a single bench press of 300 pounds? Okay, did they give me N or M? M. So we were given the function, so they therefore are asking us to find the variable. All right, so this is going to take me back to my table, because you can look at your table. This is N. this is M. And I see 292 and I see 312, but I don't see 300. So I'm going to try to find something closer to 300. So we know it's between 5 and 7. So what am I going to do on my calculator? What am I going to do to narrow my search? I'm going to go to my table set. So second table set. So now I'm going to start at 5. Now we went by 2s. You could go by 1s, but that's still probably not narrow enough. So I'm going to go by 0.1. Once I change the table set, my equation is still in there. So I go second table and notice how it starts at 5 and it's going by 1s. Now, we're first most likely going to find something that's an approximation. So we're looking for 300, right? All right, so there I get 5.7, 5.8. Here we get at 5.8, we get 300.04. So this would be an approximate answer, right? So if I were on a test, I would probably say approximately 5.8 years. No, not years. Correct me. Repetitions. Sorry about that. And then when I go put that into WebAssign, it tells me I'm wrong. And so I start searching and I go, oh, yeah, it told me to round to the nearest whole number. So what would this number be rounded? 6. So be careful of rounding. Okay. All right. Now, several times throughout the semester, we will deal with what I term business functions. We've kind of hit on them a little bit already on the test we just took. And when we start reading through this, I think you'll recognize it. But business functions, there are 3 specific functions that we look at. We look at what we call cost functions, revenue functions, and profit functions. Because if you're going into business, you're going to deal with all of those, right? Cost is how much money is going out. It's what you're spending to run your business. Revenue is money coming in. People are buying stuff. So how do we figure out our profit? Yeah, revenue minus cost. You take what's coming in and subtract the cost, okay? So that's kind of just the overview of the business functions that we're going to be looking at. All right, so the first one that it talks about is your total cost that we're going to call C. All right, the total cost C for a manufacturer during a given time period is a function of the number of items produced during that period. To determine a formula for the total cost, we need to know the manufacturer's fixed costs. Hey, we're familiar with that, as well as the cost for each unit produced. Variable cost. Hey, we're familiar with that. You guys did a cost function on the test. Remember, it was the was it the shipping? For some reason I'm going, yeah, it was the shipping one where you had fixed costs and then you had the cost per pound. All right. All right. So how do we write a cost function? That's what it's telling us right here. to find the total cost, which is our cost function, we multiply the variable cost. Take the variable cost. And we will multiply that times the number of items. The number of items produced during that period, and then add the fixed costs. And you guys did that on the last test. We've seen that. All right, then we have our total revenue function, which is called R. So the total revenue R for a manufacturer during a given time period is a function of the number N of items produced during that period. To determine the formula for the total revenue, we need to know the selling price per unit of the item. To find the total revenue, we multiply the selling price by the number of items. So this would be like if you owned a shop that sold shirts, you sold the shirts for $20. How many did you sell? And that's the revenue. And then lastly is our profit function. Now, profit could be positive or negative, right? You can make money or lose money. The profit P for a manufacturer is the total revenue minus the total cost. So here's how it tells you. It is your revenue minus your cost. Now, we just briefly hit on it. If this number is positive, then you're making money and you what we say turns a profit. If the number is negative, then you have a loss. One thing that we're also going to be looking at is what is called the break-even point. The break-even point, you're not making money, but you're not losing money. So what is your profit at? Zero. So this is when your profit equals zero. That's what we call the break-even point. All right, so we're going to do all of those in this problem. A manufacturer of widgets has fixed costs of $100 per month, and the variable cost is $55 per widget. So it costs $55 to produce one widget. Let N be the number of widgets produced in a month. All right. Well, we're going to do 3 different functions, so I'll define them down here. Find a formula for the manufacturer's total cost C. All right, so we're going to look at and write our cost function. And they told us to call that what? C. So I'm going to write function C, that's your total cost. And they told us that we are going to call the variable what? N. And N is, let N be the number of widgets produced in a month. So I'm going to put number of widgets. Okay. All right. So now look up above where we wrote out how to write the cost function. We're going to follow these steps right here. So our cost function is the variable cost. What is my variable cost? This right here is your variable cost. And we will multiply that times the number of widgets. which we're calling N. That's your number of items. Plus, what is my fixed cost? That's your $100. So plus 100. So that's your cost function. Part B, the manufacturer sells the widgets for $80 each. Find a formula for the revenue function. All right, so now we're going to do the revenue function. So my function changes. So my function is no longer C for total cost. It tells me to call it R, which is total revenue. Did the variable change? No, it's still in number of widgets. All right, so look up above. We were told that the revenue function R is equal to the selling price. Okay, what is the selling price? Okay, sells for $80. So 80 times N. All right, use your answers from parts A and B to find the formula for the profit. So now we're going to do the profit function. So now my function changes to P for total profit. And what about the variable? Does it change? No. Number of widgets. Okay. This one takes a little bit more work because if you look above, we know that profit equals revenue minus cost. So my profit is revenue, 80N minus cost, which is 55N plus 100. But here's where you have to be careful. You have to put your cost function in parentheses because it has to represent that you're subtracting all of that. And if you don't put it in parentheses, you are only showing that you're subtracting 55N. Because what we will do is we have our 80N, and then we're going to distribute this minus sign through. So we will take minus 55N and then minus 100. And then your 80N and your 55N, well, if I have 80 widgets and I take away 55 widgets, how many widgets am I left with? So I have 25N minus 100. This is your profit function right here, which required a little bit of math to it. All right, this says determine the break-even point. Well, we talked about above what happens at the break-even point. Profit is equal to 0. So the break-even point is when your profit is equal to 0. So I'm going to take my profit function, 25N minus 100, and what am I going to do? I'm going to set it equal to 0. And now what we're going to do is solve this equation for N. So pull out some of your algebra from your background. I want the N by itself. So first I have to get rid of minus 100, so I'm gonna do its opposite. I'm gonna add 100 to both sides. It'll get rid of it on this side, and I'm gonna add 100 over here. So now I have 25n equals 100. And 25n means 25 times n. To undo multiplication, we divide. I want to get rid of the 25. So I'm left with n equals 100 divided by 25 is 4. And then I've got to remind myself, what does n represent? Widgets. Okay. All right, we're gonna get through, I want to get through A and B of the practice. So I want you to read through. I want you to enter this equation into your calculator, and I want you to create the table. Pay attention to where the parentheses are, because this X is inside the parentheses, not outside. So be careful on that. All right, so it should look something like this. Now, I took the time to define my function and variable. And when you read through that, you can see the letter they're using is V, and it says it's velocity representative of feet per second. And T is your number of seconds. So when I have a question that asks you for the table, of course, you don't have to show me the X and the Y, but everything else you need to show me. If you just give me this, I'm gonna count off. You have to label your variable and function, okay? So think about this, we're skydiving. Well, not me, nor would I. No way, not gonna do it, but. So 0 seconds have passed, you go out the window and you're dropping 104.99 feet per second. Then 10 seconds later, your speed is now 147.35 feet per second. So, okay, that's where you're at. All right, so we can see that this function, the velocity is doing what? Increasing at a decreasing rate, okay? But it just asks for the table. All right, part B. Describe how the velocity of the skydiver changes with time using average rate of change to support this. Now, you just told me the velocity is increasing at a decreasing rate. That's what it's asking for. But it wants you to show it using average rate of change. So anytime we do that, and it doesn't specify, we always choose the first two and the last two. All right, so I'm gonna do the average rate of change from 0 to 5. It's the difference in your function. So 104.99 minus 0 over the change in your variable, 5 minus 0. So I'm going to go to my calculator. Again, this all stays in here, but I can clear the screen by doing second quit. And now I want to put this in. So alpha y equals 1. 104.99 minus 0. And in the denominator, 5 minus 0. And then I hit enter. And so I'm going to have 20.998 per 1. So what's going on per 1 what?
Second.
All right, we're dropping that many feet per second. All right, then we're gonna do the average rate of change from 15 to 20. Change in your function, so this would be 171.34 minus 164.44. Change in variable, 20 minus 15. You guys get 1.38? 1.38 feet every second. So you can see when she started, she was dropping a lot faster, almost 21 feet per second. But then after from 15 to 20 seconds, it's just dropping 1.38 feet per 1 second. So then the describe is like the explain, and I won't say the table is, what's our function, the what? Velocity. Is, and you told me it was doing what? Increasing at a decreasing rate. And again, I'm gonna look for this, this, and this. Okay. All right.